What is the significance of work done in a Carnot cycle? Imagine a machine that can convert heat into work with perfect efficiency. Sounds like science fiction, right? Well, the Carnot cycle is a theoretical model that shows us the maximum possible efficiency any heat engine can reach. The work done in this cycle is the actual energy that the engine produces as mechanical work from heat absorbed from a hot source. This work is important because it tells us how much useful energy we can get from heat transfer between two temperature points. The Carnot cycle consists of 4 steps involving a working substance, usually an ideal gas. These steps include 2 processes where the temperature stays the same, called isothermal processes, and to where no heat is exchanged, called adiabatic processes. The cycle operates between a hot reservoir at a higher temperature and a cold reservoir at a lower temperature. During the cycle, heat flows into the system from the hot reservoir. Some of this heat is turned into work, and the rest is expelled to the cold reservoir. Now, why is the work done in this cycle so significant? First, it sets a limit on how efficient real engines can be. The work produced relates directly to the maximum efficiency, which depends only on the temperatures of the hot and cold reservoirs. The bigger the temperature difference, the more work can be extracted from the heat. Second, because the Carnot cycle is reversible, the work it produces is the most energy that can be obtained without increasing entropy or losing energy to irreversibilities. This makes it a perfect benchmark for real engines, which always produce less work due to friction and heat losses. Third, the work done in this cycle helps us understand the second law of thermodynamics. It shows us that not all heat energy can be turned into work, and it helps define an absolute temperature scale that is independent of any specific material. Lastly, even though no real engine can follow the Carnot cycle exactly, studying the work done in this idealized process guides engineers in designing more efficient engines and refrigerators. It provides a standard to compare real-world performance and find ways to improve energy use. In simple terms, the work done in a Carnot cycle measures the maximum useful energy an engine can produce from heat. It highlights the limits of efficiency, illustrates fundamental thermodynamic laws, and helps shape better energy systems.